Oh.
It's not.
Gotcha.
I like that. She meant to keep humor. Because I said, K&T.
All right, who we missing today besides Lewis?
Yeah.
Has he gotten to the point where he just builds in class?
Louise. I don't think there's not enough Saturday schools left.
No, they are.
How do you come back from this? Yeah, you just don't get your, you walk across.
He can always grab her.
Yeah, but then like if they offer something things like that, what's the point? You can come to school, you can still like.
That's the classes they give out.
Oh, dang.
All right, other than Lolly, do I have any more openings before I hand them back?
It's not November anymore.
I know.
Oh,
Nope, December the 3rd.
That's disgusting.
Something about.
No, like you said. And I feel like I should put him understand what like usually what they were talking about. I don't want to know about I don't like it.
Better than zero, you don't have all. 3, 4, 5, 1, 2, 3, 4,
I'm a big girl, 13.
I was like, you couldn't let me go.
You know, I just
Alright, question 1. What's KMT?
Kinetic molecular.
Yeah.
That is not the answer.
What?
I never want to know what the letters stand for. We did this with EMR.
Oh, idea.
We should be wise to that by now.
Don't matter, or always.
There you go. Alright, Lolly, tell me what it is.
Idea that particles in a sample of matter are always in motion.
Alright. Because remember, the first 10 questions on the test next week are going to be not free response, they're multiple choice. They are not going to ask you what the letters KMT stand for.
Is that our only test before Christmas break?
I really hope not. You have to have a benchmark. So the only question is whether it will be a true benchmark or whether I'm going to pare down the material that we've been working on.
Okay.
What does that mean?
What does that mean? You want another test. All right. What are the conditions for the ideal gas? There are 3 of them. What are they?
Idea that particles.
They have to be what? There are 3 conditions. What are they?
Non-polar.
Nonpolar molecules,
High temperature.
high temperature, low pressure.
Alright, so one of y'all.
Non-polar molecular.
Nonpolar molecules, high temperature, low pressure. All right, number 3, there are 5 possible answers, and I asked for 3 of them. All right, so give me 1. If you would actually do the opening instead of sitting there talking, you would have these answers when I ask them. One of these days, I'm going to make the opening the quiz when I walk in instead of an opening.
Oh, no.
Oh, yes.
I just said 3.
Okay, what are they, Sailor?
Expansion, compressible, and low density.
Okay, there's 3 of them. Expansion, compressibility, and low density. What are the remaining 2? Fluidity and diffusion. Thank you, Alex. What is an elastic collision, number 5, before we do the maths one? Or the one that requires some math? an elastic collision? Go ahead, Anthony. Say it loud enough they can hear you.
No net loss of kinetic energy.
No net loss of kinetic energy. All right, number 4 should have been the easiest one because it's a math question. What's the answer? Anybody got it? Nobody has the answer to number 4. You should already have the answer. We've been in here 10 minutes. I hope you find the answer because I'm not going to work it. All right, let's talk about homework answers. And if you don't do any better tomorrow, I'm not even going to go over the opening. You can find the answers on your own. I'm done giving free answers for the opening. You either do the opening or you get no answers to the opening. We're heading for ridiculous with this now. Question number 1 on the homework. Let's start with the easy conversions. We'll do the odd numbers like I asked. If you did the even numbers, the answers will be up here on my desk and you can check. Question 1. Who are my absent people and need this so I can go ahead and give you the papers? Just Annette? Nobody else was absent besides Annette? I seem to have too many papers in my hand up here, so I feel like there was somebody besides Annette. Really, just Annette? Okay. You're going to need this sheet for homework tonight. So, was anybody else absent besides Annette? Okay. All right, so number 1. You should have 311 Kelvin. Number 3, 1.25 liters. Number 5, 0.169 moles. Number 7, 6.33 times 10 to the 4th PA. And number 9, 389 kPa. Questions? What?
The last 3.
Can you give me the numbers?
Yeah, I got, wait to the question.
Yeah. Thank you. Number 5, did you remember that nitrogen is diatomic? It should have a mass of 28. I will solve that issue. Number 7, you had 475 mmHg. mmHg on the bottom.
Yeah. I just didn't know what to write for the second mmHg because we didn't have like it changes from those.
760.
Okay, I did that.
And then PA is 1.01325.
So you don't just put 1?
No, you only put 1 next to ATM. And you said the last one's number 9, 3.84 ATM, ATM, KPA, ATM gets a 1, KPA is 101.325. Questions? Anything else on the converting? You will see conversions in the questions. And these are a standard deduction if they're wrong in any of the questions. At this point, I expect you all to be able to convert. So if you can't, I just mark them wrong.
What's the number 5.169?
Yes, ma'am. Hello, Marissa. How are you today?
Good.
Good.
How are you?
I'm good.
Good.
Anybody else? Question on that before we do 5 and 6 on the other paper.
What was 7?
7 was 6.33 times 10 to the 4th, or 63,300 something.
And then what was 9 again?
389. We done? All right, looking at 5 and 6. All right, 5 and 6 were Boyle's Law. All right, so number 5 should have an answer of around 140. Some of these are rounded for significant digits. I will not take off for significant digits, so I do not know what the exact answer is because the book is rounded.
At 141.
That's fine. All right, number 6, 38.8 kPa. Questions on either of those two? It should, let's say this, you should be very close in significant digits. When you look at question 6, at this point, we can all look and see that those all have how many significant digits? 3. So if you're at 2, 3, 4 significant digits, I'm going to be happy. If you write down 7 or 8 significant digits, I'm going to take off for significant digits. Okay? Does that make it a little clearer?
Yeah, I just didn't think we were counting.
Okay, I'm not. But if you write down a ton of significant digits, I'm going to take off. Okay? I'm not going to take off if you're within 1 or 2. Anybody else? Question on what we've done? No? All right. Try to take out the earbud. Okay. I believe you, but if Miss Curry walked in, she'd have a stroke. And I'd hate to have to throw you under the bus because it's you or me, and you're going before I do. All right. Questions? All right. If you will, find your notes. We have 1, 2, 3, 4 gas laws I want to do today. So let's see if we can get those done. The weather doesn't look all that great for next weekend, so I have fears about next Monday if that storm actually comes.
Staff members, we have the parade that will take place today. And normally on today, we have an abbreviated staff meeting. This year, the officials that are in charge of the parade have asked that we clear the building much quicker. In consideration of that, we made a suggestion or attempted to change the staff meeting to tomorrow, but it will cause too many complications. Therefore, we will have the staff meeting today. I'll ask that you clear your hallways quickly and get to the media center at 3:30. There will be no after-school bus, which has been the practice every year when we have the parade. So there will not be an after-school bus today. So if you have talent show practice or any tutoring or other after-school events, they must be canceled and should not have been planned on a staff meeting day anyway. Thank you, and let's have a great morning.
Apparently we are.
Oh.
Well, at least I don't have to move my, now I don't have to move my test corrections.
Well, good, now they don't have to be marked enough, because I was just saying, they're gonna book us like January. Because, I mean, everybody's staying until then.
I would just have assumed they'd have bumped everybody back, which would have,
But you know,
yeah. I mean, I wouldn't have fixed mine any better than it is. It just works better to do it today.
I'll just be late anyway, so we gotta get home. Mommy done by the time I get in there.
It's possible.
They're really late.
Nah, Thornhill's long-winded. Thornhill's long-winded. Oh, yeah.
Oh, I'll be late to that tomorrow too. You gotta be home then. He'll be here soon.
All right, so now that the staff meeting is back to today, nothing's changed for tomorrow, which is why I hadn't said anything yet, because I didn't know if they were going to move the staff meeting back to today. Test corrections are tomorrow and Wednesday of this week, tomorrow and Wednesday of next week. So you have 4 opportunities for anybody who wants to do test corrections. How many people do I have who still need to take the test? Because I've completely forgotten. I have Karina and Lolly. So if you guys want the opportunity to do test corrections, the faster you get the test made up, the more opportunities, of course, you have to do test corrections. So, yes.
They said, like, as we do test corrections, you'll put that grade in.
Yeah, so if you do test corrections tomorrow, my practice is usually that I go ahead and mark the points that you got either that night or the next morning during my planning period, and I go ahead and add those points to your grade and put them in PowerSchool. So I don't wait until not this Wednesday, but next Wednesday to add them all up because it's a little overwhelming to me to have to do all of it one time. So I just do them as we go each day. So let's say you had a 50 and you earned 8 points that day. I'll go ahead and change the 50 to the 58. And you come the next day and you earn 8 more. I just change the 58 to what, that's a 66, I'll change it to a 66 and keep going, kind of
Does that
thing.
mean if we don't finish all of it, we do get credit for what we did do?
Mhm. Yes. And some people only come once and they never return. And some people are diligent and come 2-3 days. And I just add the 2 or 3 days together as you do it. So it's completely your choice. And some people will never do any, and that's your choice too. Okay. But this will likely be the only test that has test correction, simply because the second one we will take will be right at Christmas. When we come back from Christmas, what will we do after Christmas? Review. And I will tell you now, the way I've always done review for chemistry is it's after school. It will include bonus points. They'll go on second quarter. Do not misinterpret what I just said. The half a point goes on which grade?
Second quarter.
That's right. Several of you are going to try to convince me that I said what grade? Final. I did not say final. I said second quarter average, not the final average. And I will do it. So there are 3 opportunities. If you come all 3 times, that's 1.5. 1.5 rounds to what? 2. Now, if you only come twice, that's what? That's 1. 3 rounds to 1.5. 1.5 rounds to 2. All right? And we will do that when we come back. I don't know exactly when the exam is. So all review, for the most part, is done after school. I will do no more than 2 class days, and sometimes it's only 1.5 class days of review in class. So those of you who never stay after school, your review time is going to be very limited compared to the people who come after school.
So what are we going to be doing in class?
Largely continuing on with new material, because we will not finish the curriculum. We're 3 days behind now from where we normally are, thanks to the hurricanes. And if the storm they're calling for this weekend materializes, they're calling for snow this weekend for those of you who don't ever watch the weather. Okay? I know.
It can wait till Christmas.
It could wait till Christmas, but it doesn't appear that that's... Now, if it shifts, and Miss Rector and I are praying for a shift left or right, and if it does, and it misses us, please pray for that, then we'll be here Monday. Okay? Depending on the cold weather and where it lands, it is conceivable that we could miss school Monday. If we miss school Monday, odds are we could not make up that day until what semester? Second semester. Third. We don't have a third semester, thank God. All right, but it would be third quarter. So we would lose a 4th day this semester. I'm not going to be able to get that day back. So that's just where we are.
So if it's like, still for just one day or just like combined?
What, that?
Yeah.
That's all one day. There's no way to get it shortened. Now, I could give you stuff to watch to help catch up. But the problem is, when some of y'all are out, y'all don't watch what you missed. Yet, you want me to tell you to go watch something in advance?
So have you are the things we're behind on important?
Yes.
Just like small things.
Depends.
You know,
Now, I will give you tips to help you eliminate. And if you want to see what you're missing, I'll be glad to stay after school to teach it. But that's up to y'all. But moving on, so we get what we need for today. Charles' Law. So Charles' Law is like Boyle's Law in the sense that it's the same kind of law, but the variables are different. This one is volume and temperature at constant pressure. Now, Boyle's Law was pressure and volume, and it had constant temperature. So Charles is going to be constant pressure. Now, just like when we did Aufbau, Hund, and Pauli, and you didn't have to know who said what for the exam, but you did for me, same concept here. You do not have to know Boyle, Charles, and Gay-Lussac for the exam. You don't have to know that Boyle was constant temperature for the exam. You do have to know him for me. Okay?
and what is the point of that?
Exactly. It's all extra. Now, so let's say that we have a container. All right? And we have to have a thermometer because this one has temperature and we've got to be able to measure it. Okay? Temperature equals 25 degrees Celsius. And again, are we changing the number of moles?
No.
No. Okay, so remember, the particles that we're drawing in, all right, so the moles are constant. Because remember, we're not changing those. We're not going to change those until at best late tomorrow in class. So the particles are not going to change. So our temperature we're going to have at about 25. Now, we're going to change the temperature to, let's say, 75 degrees Celsius. So my question is,
What is that in comparison to like the temperatures? Not like the conversion, I don't want to do that.
Oh.
I just want to know, like,
I'd
I know 0 is freezing and 100 is boiling, but I don't know what, like.
have to calculate because I don't know.
Like, is that important?
No, it's not. No. I mean, I'd have to convert it because I don't know what it is either. I mean, 25 is a little warmer than room temperature. I mean, most of us would probably be in shorts and a t-shirt and might even think, all right, it's a little toasty at 25. Okay. 75 would be really warm. You would probably struggle to put your hands in that. Okay. All right. What happens when temperature increases? All right. Tell me what happens in the container when the temperature increases. Okay. All right. So we know that particles speed up. So what happens inside when the particles speed up? Okay. Spell it right, stupid. All right, I need a little more. All right, what does that create? What?
More pressure.
Yes. All right, it creates.
So that creates pressure?
Yes, when they bounce off each other. All right, they not only bounce off each other, we add in something else. They bounce off, yes, and the container walls. Which creates greater pressure. Okay? Now, we said that we want the pressure to remain constant, right? So, how can volume be changed so pressure remains constant? All right. Chris says increase it. So we have these particles that are bouncing around the container. All right. If we increase the temperature, they hit the container walls more often. Does that make sense? Okay, so we have these blue dots that are our gas particles. Everybody with me on the blue dots are the gas particles? If we increase the temperature, what happens to the blue dots? They go faster or slower? They move faster. So do they hit the container walls more often or less often? More often. So if they hit more often, the pressure goes up. Are you with me on that? Okay, we don't want the pressure to go up because Charles' law says pressure has to remain constant, right? So the only way we can keep pressure constant is to change the volume. So the question is, do we make the volume bigger or do we make the volume smaller?
Bigger.
All right, so we all agree with Chris, we need to make it bigger. Okay, so we're going to make volume bigger and give them more space to move around. All right, so we will increase the volume so molecules have more space. Okay? So we increase the volume so the molecules have more space.
So for the exam, we just need the formulas.
You're largely gonna have to know the formulas, and you might have to be able to analyze something like this. I'm gonna show you how to get the first three formulas, Boyle's, Charles, and Gay-Lussac. I'm gonna show you how to get out of this one, which is on the formula sheet. I'm gonna show you how to get it off the formula sheet, which is on the formula sheet. All right, does everybody have what they need? All right, so what is Charles' law? Pressure. Oops, sorry, I'm doing Gay-Lussac's. Volume and Kelvin temperature are, tell me this. What do we do to temperature? What happened to volume? So, what am I going to say here? All right, so volume and Kelvin temperature are directly proportional at, hold on, we're going to talk about that, at constant pressure. And I'll just write and moles again in parentheses because we've already said we're not changing moles. All right, my S is a little jacked up there. All right, so the formula for this one is V1 over T1 equals V2 over T2. And if you think back to Friday, when we did this Friday with Boyle's law, what variable was missing in Boyle's law? Temperature. Because temperature was what? Constant. So today, what variable is missing up there?
Pressure.
Pressure, because what's constant?
Pressure.
Pressure, okay? So when you're solving the gas laws, if it says pressure is constant, you want to pick a formula that doesn't have what in it? Pressure, and this formula doesn't have pressure in it. Does that make sense? Make sense, Devontae? Okay. Okay, well, I'm trying to ask people who I know the math is not their thing to see if what I'm saying makes sense. I know it makes sense to Chris. He likes the math. But does it make sense to you and Lolly? Because math is not something you enjoy in here. It doesn't make sense to you.
I mean, it doesn't, it doesn't. I mean, it makes sense. It's just no matter what.
Okay. Now, for Caroline, she said, I thought we were doing Celsius. Where's temperature at in the formula? Okay, so why are we using kelvins?
Because it's like,
Okay, why can't I use Celsius? Let me ask it that way. What numbers can we get with Celsius that I don't want? Okay, and if I use a negative number, what kind of volume am I going to get? Okay, I want a negative volume. What else would be a problem if I have a temperature that's in the denominator and it's Celsius?
Not everyone uses Celsius.
Well, that's not what I want. I'm only looking at a math standpoint. Nope. I have decimals. Nope. We don't want negatives, and I don't want this one number in particular.
zero.
Can't have zero in the denominator. And I can have zero on the Celsius scale. So what happens if I have zero in the denominator?
Or one, no.
Almost be right.
It's itself.
It's good happens if you have zero in the denominator.
I don't remember.
It's what? It's undefined.
What math is that?
Exactly. I couldn't have told you more curriculum. Okay, it's undefined when you get there, when you put zero in the denominator. It's an undefined number. You cannot have zero in the denominator. You'll know that when you get there. You taking that next semester? You're ahead of the game. You're ahead of the game when you get there.
We're
Okay.
ahead of the game by one turn.
Okay. All right, you cannot have zero in the denominator. It's
I think
undefined.
I learned that somewhere.
Okay,
Somewhere.
Just don't.
that's why we use Kelvin numbers, because you can't have negatives, you can't have zero. All right, so write that down and we'll solve. And I'll see if I can't point out some things to make life easier for my people who hate math.
How much space do we need?
Not much. You can do it in that amount of space you have right there, I think. Just don't write real big. Yep.
I did these with the VNP and VNT or whatever, but with like, when we have to do all the other ones, like KPA, I don't know what numbers to put next to the like on the homework.
Say it again. I started a text message to somebody.
Like, I don't know what numbers go to the units. So
Like when you're converting,
yeah. Like, I don't know how to choose which one.
it's based on the number that's right here. So 760 goes with MMHG, 760 goes with TOR, 101 goes with KPA, and this number goes with PA. One goes with ATM every time. Does that make sense?
Yeah. You only have one with, yeah.
ATM, yes. Okay, you were bigger than I thought. I might have been wrong. Alright, so if we look at what you've got up there, alright, what's going to tell you that it's not Bull's Law like it was over the weekend, if you bothered to try those questions? What gives it away that it's not Bull's Law? Alright, couple things to look at from non-math people, okay? You see how it says pressure remains constant? Alright, if you had picked P1 V1 equals P2 V2, like we did over the weekend, or last Friday, if you didn't try anything. If you look at what we did Friday, if pressure remains constant, what are you putting right there? You have no numbers, right? Because I didn't give you any pressures up here. When you see an ml, what is an ml? Is that a volume, a temperature, or a pressure? That's a volume. What is a Celsius? That's a temperature. What is a Celsius? So do we have any numbers to put in for pressure? That's what tells us we're not going to pick that formula. Does that make sense to my non-math people? Okay. So that's how we know that we're going to use volume 1 over temperature 1 equals volume 2 over temperature 2 because there's no what in that formula? There's no pressures. Does that make sense? Okay. So 752 at 25. See that at word? Remember we talked about pairs and couples last Friday? That's what that is. That at shows possession. That 25 has to stay with that 752. You can make it V1 and T1, or you can make it V2 and T2. Doesn't matter as long as it stays together. Okay? I make it V1 and T1 because they're where in the question? They're first. But it doesn't matter. They can be V2 and T2 because they're together. Now, what volume is going to be V2? And 50 degrees Celsius for me is going to be T2 because it's the second temperature. Yes? Did somebody say they had a question? No. I'm just hearing things now. All right, now, I told you Friday, the units must match, which is still true. However, there's a second catch to these kind of questions. Temperature must be Kelvin. So, not only do the units have to match, So if you had been given two volumes, the two volumes would have to match. Now the temperatures have to be in what? Have to be in kelvins. So, yes. I'm just trying to wet our feet first. All right. So 25 plus 273. So everybody knows I'm using K equals C plus 273 to do this, right? So I'm just saying 25 plus 273. So I get 298 Kelvin. And then 50 plus 273 is 323 Kelvin. All of them have to be Kelvin. That will never change. There's only one formula, and you'll hear me say this a lot between now and the exam. There's only one formula that we do not have to put in Kelvin, and that's specific heat. Okay? That one can be done in either. But gas laws always have to be done in kelvins. All right? So our formula is V1 over T1 equals V2 over T2. And I know you didn't like my term, but this is just plug and chug now. So 752 over T1, which is 298, equals V2 we don't know, over T2, which is 323. Now, at this point, you've done all the chemistry. You are simply relying on your math skills. I cross multiply. Okay? I cross multiply.
But you can just multiply on the side.
You can do whatever you want to do.
I feel like I should. There's no way how.
All right. What am I going to do to get V2 by itself now? I'll divide by 298. Now, those of you who have weaker math skills, cross multiply and get rid of the fraction. Those of you who have better math skills, do it whatever way you want. Okay? It does not matter to me. But if you have weaker math skills, cross multiply and get rid of the fraction. Now, my units had to match, right? So my V2 has to be what unit? Questions? Think you could try one?
No, wait.
Maybe.
Why not? Everybody got what they want off the board? All right. Now, you've already got a sample written. Don't write the question. Just work it. No, you don't need that right now. Yeah, you do. Write that down because I always forget to teach this. And then it pops up somewhere. All right. We're going to use abbreviations, and you're going to see abbreviations. You will see the words STP, or I should say the letters STP. All right. STP means standard temperature and pressure. Now, if you forget what STP means, have no fear. It's on your reference table. It's in that top block on the front page. Okay? So if you don't write it down and you need to look it up, it's there. You just have to go to the front page of your reference table and find it. Now, sometimes they will write the words, the letters STP, and sometimes they won't. They just write standard temperature. When they say standard temperature, they're giving you a number. They're giving you the temperature, 273 Kelvin. When they say standard pressure, they're giving you 1 atmosphere of pressure. If they say STP, they're doing what? They're giving you both. They're giving you standard temperature and they're giving you standard pressure. So they're giving you both of those numbers. Okay? A lot of times when I do this the first time, students tell me, that's why you didn't give us any numbers. Yes, I did. If I give you those letters, I've given you both of those numbers. Okay? Everybody have it written down? But you can look it up if you don't remember them, because they're on the reference table. I don't know why, but I guess they looked at the forecast, saw 65 today, and they decided we didn't need any heat. I don't know what to tell you. All right, everybody got it? All right, here's our practice. Again, don't write the problem down, just solve.
Do we have to change it back to Celsius?
Yes, if it asks for it. If it doesn't ask for it, then I would leave it in Kelvins. That would be my advice. All right, we're ready? More time? Where are we at? Okay. Now, if you're finding this to be easy, the nice thing about Boyles, Charles, Gay-Lussac, and the combined gas law is they all work the same way. That's the nice part about this. Dalton is different, but the rest of them all work the exact same way.
All these guys go to the quiz.
Yes,
What's that?
Wednesday. There's 5 questions, one of each. And when we take the test, I'm pretty sure I'm gonna skip the one where it's over water. So I'm gonna need you to remind me to give you the answer to one question. This is a multiple choice. I figured you would. That's why I told you that. because I knew you wouldn't forget. All right, caught up? Had a chance? Calculated it? Where are we at? I just make a really weird face. I don't think it's the style. You got a question?
I want to ask, explain.
Okay, so you have, that's clearly she wants me to explain. All right, do you want me to do the whole thing? All right, so volume 1 is 2.75 liters. Temperature 1 is 20 degrees Celsius. Volume 2 is 2.46 liters. We're solving for temperature 2. Now, we always have to change it to kelvins. Now, what if the question had said, what is the outside temperature in Celsius? Could I leave it in Celsius and solve it in Celsius if the question wanted it in Celsius? No. Even if it wants it in Celsius, I still have to change it to what? Kelvin. So I'm going to say 20 plus 273, and I get 293 K. All right, so plugging in, I have V1, which is 2.75 over 293 equals 2.46 over T2. All right, so I'm going to cross multiply, and I get 2.75 times T2 equals 293 times 2.46. And I need to solve for T2, so I'm going to divide by 2.75, and I'm going to divide by 2.75. So 293 times 2.46, divide 2.75, I got 262. Now, Caroline asked, do I change it back to Celsius? The only reason I would change it back to Celsius is if the question said, what is the temperature in Celsius? If it doesn't say that, I would leave my answer in kelvins, okay? The units had to match, so I know my answer is in kelvins, okay? Question, anybody? You feel okay about it? Did you do it right?
Yeah, I know what it was.
Okay, so you can fix it. Okay, Gay-Lussac's law. All right, so Gay-Lussac is a hyphenated name. I don't know anything about the man. It's his last name. Now, this one is pressure and temperature at constant volume. This is the one that goes with the idiots who like to put aerosol cans in fires. Go ahead.
Would it blow up?
Yes, it will. Every day of the week. Now, if you have a canister, no, same one. The good news is it's the last one we're drawing. Okay?
I just still don't understand what that is.
It's a thermometer.
I get that, but I don't know what anything else is.
It's a gas canister. It's a cylinder. It's a box. It's anything that contains the gas molecules. The blue dots are the gas molecules. Yes, sure that. Only a gas is trapped in there.
I'll start drawing mine as a boy.
Draw yours any way you want to. Okay? Now, if, all right, and this time we know it's going to be 1 liter. We're not changing the volume. All right, here. Let me see if I can make it the same size. I don't know if I can. I'm not very talented with this.
They took it away, didn't they?
They did. I hit Control T.
What if I would have been much?
I was like,
I had to eat
my
my
food
food
in
cold.
the microwave. I was like, why didn't we get rid of that? This is for
I don't think the microwave had anything to do with that. I thought they put it in.
The microwave couldn't make the fire, it's only because it can't even down. It still be cold. So how can it make a fire? I've never heard of that popping that microwave. It won't.
It don't spin, that's why it can catch something on fire. You right, cause
My
my
microwave
microwave
doesn't spin at home and we caught a hot dog on fire. Because two heats were touching, so it's caught fire.
I tried one was a popcorn and that too. It was one spot that was burning. And it wasn't that.
I just morning, and there was just rice in the microwave. Like a pile of uncooked rice.
Why?
However, we gotta do something with it.
Wait.
No, just on in the microwave.
That's just it.
Yeah.
Yeah.
Wait, is this like?
Is one supposed to be better than the other?
Is one what?
That says 75.
One says 25, one says 75. Volumes are the same.
Can I warm this up?
Yeah, you put there, but I just forgot.
They're supposed to be.
You're supposed to be the same size. Hey, I copied it, so I hope it's the same size.
Okay,
It
What?
looks, it was so awesome, it's a little bit lower than the other.
Huh?
can I warm this up again before we get started?
I don't care. I mean, it's my microwave, but the staff treats it as a communal microwave, so go right ahead, knock yourself out.
Okay.
Oh my god, you're saying. Well, nobody gets it on that. We don't really get it.
Yes.
Sorry, we're
Right, Miss loves things
She's
with my
not
microwave.
suspicious.
I just like to be asked, at least I'm not asked, so it's fine.
She got a whole minute for you. What's this picture?
That's what I would do. Tomlin got a whole fury in his office.
All right, is everybody happy? Now, what can you tell me we did the temperature? Today you're gonna survive over there? Yeah, well, I didn't know, your head's down and your legs just bobbing like you're gonna die. You okay? Okay, so what happened to the temperature? The increase. All right, we're not changing the volume, so what's gonna happen to the particles inside the container? I said, what happened to the particles?
They're gonna squeeze.
All right, they're gonna move more. So if they move more, what are they gonna do more often? All right, so the particles move faster. They hit the walls more often, which causes what to happen? Pressure will increase. All right, so we should be able to write the law then. So pressure increased. We already said temperature did what? Okay, so tell me what the law says. Pressure and Kelvin temperature are directly proportional at constant volume.
Wait, what was the other one that was directly before?
There was Charles' law, volume and Kelvin temperature are directly proportional at constant pressure. And I'm going to again write and moles in parentheses. All right, so this formula is P1 over T1 equals P2 over T2. And again, notice there's no volume in the formula because volume is what? I just said a minute ago, I'm going to show you how to find these three formulas
So what I'm assuming is.
from the combined gas law.
You just gotta remember.
If it's directly.
It is directly apart from the denominator.
Indirectly. It's inversely proportional, then we're gonna multiply. If it's directly proportional, we're dividing.
Yeah, directly there's a denominator, inversely there's no denominator. How long do you have to do that before the style will go away?
I have no.
No clue? Okay.
It just helps.
It's a nebulizer.
It just helps, okay. I've never had one, so I was curious.
Like, this is ridiculous.
How long have you been doing it?
I just
I just started, like, when I got to school,
Oh, okay, so when did the sty appear?
like, I woke up and I couldn't open my eyes, like, oh.
Oh, so this is today?
Yes, I was like, maybe I'm just sleepy and I just.
Okay, I didn't know if you had it all weekend. Okay.
Right, they gonna pass me by there and I'm gonna see.
You have a game today? Oh, that's a problem.
Yeah.
Ah,
That's how it's feel with glasses.
Can I use your eyeliner? You can't see with glasses.
Yeah.
No. That's
Well,
your-
see, I still can't see anything for 30 hours.
alright.
Oh,
Alright, let's see which one's shorter.
that is a lot.
That one shorter?
That's better.
Alright, let's do that one.
That's short. What'd you say?
You can't see, just write that one down. You don't get a vote, you can't see.
I'm like, this.
They voted that one was shorter. We'll do the longer one as practice.
It's just like eye drops.
No. Oh, they doing it where?
Yeah. I was gonna say, you probably just text your mom.
Oh, I'm on the.
She's not.
It's like squirrel in the. Yeah. I just saw
Brain is hard to
something
tell.
around-
Wait, like, get the
It was a squirrel.
That's what I just. I don't know what I did.
Oh, that's what she was looking at? Yeah, like, oh, she just like.
Yeah, I can't figure out what to do.
Yeah, that's something. Somebody else, you know, hit them off that way. That's it. She really does.
I hope it's not too cold. Better than 30.
Okay, that was a good score.
What is the word?
Freaked out? Cold. That's what she cried. It was hilarious.
I mean, maybe I should get like bug off or something.
I'm not even talking.
I'm not worried. Because we're just dumb. It's in the middle of the road.
Oh, I watched one Hunter Transformer get that.
I heard on the.
You know,
But it like suits it.
Yeah, I didn't know that
But you can go to,
on it first.
go to interchange.
Okay, so let it get cold and then just keep holding it there.
That's why you have to see cold ice.
I don't think she should put that on
No,
her
I'm not saying,
Yeah.
I'm not saying use it on her eyes.
You won't die, you just make a line.
It's
I mean-
But it's gonna.
You're not gonna
She just tell you to put ice out of your eye.
No, I said ice on her eyes is cold first and then it gets hot. Because hot soothes it away. You don't put it on there first. I know the cold on there first.
freeze, burn, freeze, and burn.
I'm not sure I'd listen to Denasia.
You know how many times I've been to the
No, she
doctor?
right though, she right.
Well, I believe it's been lots.
I think
Nah, she right though. It's cold first.
And they put icy hot on it.
No.
I think she's trying to say a
I'm not
combination of
talking about
temperatures.
icy hot, like, okay, when you're trying to make something like the stock down, you would put cold on it first.
Oh, okay.
And then you would put heat on it. So
Okay.
the cold
Don't
makes
say
it
that
down.
word.
Heat
My
will
doctor
soothe it.
told me.
Oh, okay. That makes sense.
Not for icy hot.
I was like, holy crap, that would,
Which makes sense.
I would, you probably every swear word I knew if you did that to me. I might invent a few.
It lowers your blood pressure.
Second costume special, that's sorry.
Oh, so you telling me?
Shoot.
You said shoot. Miss Wall, there you go.
I've been trying to
You
fly.
sweat cussing.
This
Oh,
will be
my
like my blood pressure high. She goes to the doctor's office.
Did
you start cussing when you
Oh,
No, I was actually amazingly calm.
I would have yelled at that man and tried to help him
I just see the girl like this, I'm trying to get it out.
That was pretty high. So, what do we know? What is 1.8 ATM? It's a pressure. All right, so when you see an ATM, you know this is a pressure. Okay? It says at 20. So what do you know about 1.8 ATM and the 20?
They go together.
They go together. All right, so P1 is 1.8 ATM. 20 degrees Celsius is a temperature, and it has to stay with that 1.8 ATM. Okay, they're a pair. They have to be together. So when I read 1.9 ATM, that's again another what? It's a pressure. So it has to stay with that. We'll make it P2. Now, the question says, what is the new temperature? So we're solving for temperature, but it wants the temperature in what unit? Celsius. Now, this is why I asked that question a few minutes ago. Can I leave T1 in Celsius since it wants the temperature in Celsius?
No.
The answer is no. Even though it wants Celsius, we can't stay in Celsius. I still have to change it to kelvins and solve in kelvins, but then I'll have to change it back to what? Celsius. So 20 plus 273 is 293 kelvins. So I'm going to get rid of my Celsius and change it to kelvins. Now, my formula is P1 over T1 equals P2 over T2. So, taking what I know, 1.8 over 293 equals 1.9 over T2. Any issues with what I did or how I did it? What?
Will pressure always be atmosphere?
No.
Change like that KPA?
It could be KPA, it could be torr, it could be any of the 5 units we learned. Lolly, where did I lose you? Were you with me on the last 2 gas laws? Kinda. Want me to go back and do it all again?
No. She gets it.
Tell you what, we'll do a sample in a minute where they work and I'll come do it with you. Okay? Will that work? Okay. All right. So we're going to cross multiply. So I'm going to have 2.9. Oops, that's 293, doesn't it? 293 times 1.9 equals 1.8 times T2. I'm going to divide both sides by 1.8. And I'm going to get T2. Now, when I get that answer, it's in what unit? It's in kelvins. But the question doesn't want kelvins, it wants what? So, yep, now you're going to use your K equals C plus 273. You're going to put in your 309. And you're going to subtract. You get 36.2 if you left your decimal, but 36 is plenty.
Oh, see, I just like subtracted the 273 back to 309. Is that okay?
Yeah.
Okay.
That's fine. I just wrote down the formula so everybody knows where it came from. Okay? Questions?
Hold on.
You're fine. We're used to seeing y'all punch buttons and check fire extinguishers. All right. Anybody not okay? Other than Lolly, who I'm going to work with in a minute. You with me, Almaja? You need help?
They come sit in your class and get brushed up.
They want out of here, so I'm not sure you want to be here either.
Y'all have a wonderful day.
You too.
Take me with you. Oh, okay.
Are you there?
Yeah.
All right. All right. Y'all do that one. No, don't write it down. All right, Lolly.
I'll tell you that right, and I couldn't use when I was
Okay. You want to try it, try it.
Did you start singing the song for the movies? Hey.
That's why I'm 2 semesters.
Oh, what's that? I've been in like classes. Yeah.
Diamond,
Yes.
are you working?
Of course I.
Does it sound that way?
But I mean,
Won't take you long to do it. And I'll be happy.
Let's see what happens.
Mm-hmm.
I mean, you know what? You're gonna sit by me in every class.
oh, you wish.
Do we round when we get these?
You can. I don't have a problem with it.
I know.
Yeah.
Never mind.
Well, ask. I'm not Lolly. Don't seem to need it. You can leave me to my own devices. I'm here to read my book all morning. So you better ask.
No, wait.
What?
No, it wasn't I like it. If I hide it, then I'm gonna feel.
Okay. Just sit here, stand here. Come.
No. Stand it, it's too boring. I want you to read it 2 more pages. It was 5 pages. Is this right?
I have no idea.
I don't know what you said at all.
I was having to read it.
Okay, yeah, I don't know.
Jada got the same thing.
I think that's the same thing. Where'd you erase it for?
That's nothing.
You left it in Celsius.
Oh.
Will you sign off? If
Wait,
you
Stick it up.
Ms. Wall, what I do?
You gotta change it.
You got to
I did.
Oh.
Oh, I thought you said it was wrong. Oh.
He left it in Celsius. You changed it. Now we got it.
My plan C
How do
is
you?
co-ed, not playing.
Yeah, we changed it to, is this right?
You had your temperature, so you don't change it. Temperature's your hat.
So it's just that.
Just that, right, atmosphere's on, ATM.
I'm like, I'm
Did you get it? Yes. All right. Anybody have a question? Because the two people who are still working have the answer. All right. The combined gas law. Now, the nice thing about the combined gas law. Yes, it is. Pressure,
Wait, what was the answer?
3.32 atmospheres.
So we got something close to that?
Yes, if you got something close, you're fine. Only moles are constant. Okay, so we have pressure, volume, and temperature, and only moles are constant. Now, Caroline will love this. There are no boxes to draw, so she won't tell me she doesn't understand the boxes. All right, pressure, volume, and temperature. All three of them are in the combined gas law. Only moles are constant this time. Now, this formula is on your reference table. So, this one is nice because I'm going to be able to show you how to find the other three from this formula.
This is nice for who?
Y'all. Particularly for those of you who are challenged with memorizing formulas. Now, notice that pressure, volume, and temperature are in the formula. Moles, of course, are not. We'll pick those up tomorrow after we practice. Now, everybody got it written down?
No.
Hurry up, because I need you to be able to look. All right, so let's say you have forgotten Boyle's law. But the question says to you, the temperature is constant. Now, first of all, let me tell you, this is the only formula that works this way. You cannot do this with any other formula, so don't try it, okay? The combined gas law is the only one that works this way. So you remember temperature is constant means temperature needs to be taken out of the formula, right? You can simply say, and there's Boyle's law. Erase T. All right. Let's say you remember Gay-Lussac, which we just did, was constant volume. You just take V out.
Oh, wait. What I thought was it.
You can only do it in which law?
This one.
The combined gas law.
Okay, you just, because they're all, got it.
But if everything's in there and nothing is constant, you leave all three variables. Okay? If it's Charles' law and pressure is constant, you just take out pressure. And then you have Charles' law. It works for all three laws. Okay? Does that make sense? Whatever.
It doesn't.
I'm just telling you it works. If you cannot remember the formulas, there are the formulas. All right, there's a sample, so we can work one and make sure everybody knows how to do this.
Are we doing this together?
You know I'm going to work one with you. I would do at least one sample in my notes, just so you have one. But if you don't wish to write it down, I guess you don't have to.
Oh, we don't have that.
So how did they get helium in a tank?
How did you get what?
How did they get helium in a tank?
They trap it from the atmosphere, but beyond that, I have no idea.
How?
That's why I said, no idea. Google it. On your free time, in your free time, not mine.
What was she saying? Oh, okay, so. What is it? I know it changes the picture of voice, but like it's messing with your brain.
I don't think so. I mean, it could asphyxiate you if you did it for too long and it would replace the oxygen in your blood cells.
I don't even know how to do it. 'Cause I want to go through it.
No, you
No.
I want to have.
You ever look at it?
No.
Sometimes I do not. No. I have a little team seed brown.
Everything's on weight, like.
My dad is in jail, so like.
Okay. What a kid.
Get a dog.
I already have a dog.
Get a puppy.
I already have a dog.
Get a dog.
Trust me, stick with the dog.
I don't want to be a teen mom because
Alright.
mom will actually slaughter.
Maybe that's my mom.
So, when you look at this, what's different about it?
It has everything.
Alright, so nothing is held constant. It doesn't say anything's held constant. Now, I can't remember if I said this on Friday. I'm pretty sure I haven't said it today. What if you read a problem and it doesn't say blah, blah is held constant, but it doesn't give you a temperature? What do you assume? You assume what? That it's held constant, okay? If you read a question and it doesn't say that temperature is held constant, but it doesn't give you a temperature at all, what do you assume about the temperature? That it's held constant, okay? If there's nothing there, you just assume that it's constant.
Which is about 270.
You could put in 273 if you wanted to, so you could actually use this formula and you could put 273 here and 273 there if you wanted to, but I'd be more inclined to erase it and not use it at all and do that. No, it wouldn't. But if you put 273 here and 273 here, then you just have extra steps because you got to multiply and divide by both of those numbers. But if you take it out, then you have less steps. Okay, so I'd be inclined to get rid of it if you knew it was constant.
How would it not change the
Mm-hmm.
Because
Because you would wind up multiplying by it and then canceling it out when you divided by it on the other side. So it wouldn't actually change the number. So you could get rid of it if it was constant. But if it made you feel better and you wanted to put 273 on both sides, you could. Okay? All right. So when you look at this, it tells you have 50 liters. What's 50 liters? What's a liter? That's a volume. What's a Celsius? And you have this, which is a what? So this time, instead of having a couple, we have sort of a triplet, okay? But see how you read 50 liters, and it says at 25 and 820 mmHg? All three of those numbers have to do what? They have to be together. So we're going to make them V1, T1, and P1, okay, since they're first in the question. So the 50.0 liters, the 820 millimeters of mercury, and the 25 degrees Celsius are all going to be the ones. All right, what will be the volume is going to be V2. 10 degrees Celsius is going to be T2, and P2 is going to be 650 mmHg. All right, so once you've got there, the same rules apply that have applied all day long. Okay, the units have to do what? Okay, the units must match. And I can't remember in the homework, there might be one or two that don't match. Tomorrow you will see several that do not match in our practice early in the day. All right, so this and this match, and then that will match with that when we get the answer. And of course, Celsius has to become kelvins. All right, after that, you're ready to solve. So 10 plus 273 makes this 283K, and 25 plus 273 makes that 298. Okay. All right. Anybody confused where the numbers came from or changing the Celsius to the kelvins? Nope. All right, so we're ready to plug in. So P1 V1 over T1 equals P2 V2 over T2 is the formula. So 820 times 50 over 298 equals, we don't know V2, times 650 over 283. Now, again, at that point, you've done all the chemistry. You are strictly relying on your math skills.
Oh, wait.
Cross multiply.
All I did was take these numbers and plug them in the formula. All I did was substitution. That's it. I matched up the number to the letter and substituted. Now again, I don't pick up the calculator immediately. I'm going to cross multiply and divide. So that number's going there, and that number's going there. So I have 820 times 50 times 283 equals 298 times V2 times 650. Now, I got rid of my fractions. I need V2 by itself. So I'm going to divide by 650, and I'm going to divide by 298. So I'm going to divide here by 298 and by 650. Now, you do not have to do it my way if your math skills are stellar.
Why is it two?
Why am I dividing by two numbers? Because you got to cross multiply by two numbers. Get 59.9. Units had to match, so it'll be liters. Now, I will tell you when I grade papers, if you have the wrong answer and you have a bunch of weird numbers written down on the paper where you've solved a different way and you write down numbers on the calculator, I will make zero attempt to figure out what those numbers are from. Okay? I'm just going to be upfront about that. If you have this and you have this, and I don't know what's in between this to this, other than some weird work, is a minus 10. Okay?
So what you're saying is you have to show up your work.
I'm just telling you, I won't know how you got from this to this.
Doesn't matter though, as long as I got it.
As long as you got this answer, I don't care. So make sure you double check your work and there are no calculator errors or anything weird in your algebra. Okay? Because I won't figure out how you got from here to here if there's a calculator error. I'm just going to assume your math is wrong and write minus 10. Because I won't sit on 20 papers punching in my calculator trying to find your error. I don't care how you do it. I will look at your work if it's there. But if you, most people don't, you don't have to do it that way. But if you go ahead and multiply and put down a bunch of strange numbers that I'm not going to recognize, I'm not going to multiply on my calculator to figure out what the strange numbers are. Alright, questions? Do you need one to practice, or can we talk about Dalton's Law?
Let's, do you want
No.
Okay, doesn't matter to me. I don't need to practice, I'm following y'all's lead. Alright,
No, the way you
Which one's this?
this is still combined. Alright, find me an answer.
Well, right now.
Yeah, you already got one, just solve. Now figure out what homework numbers I want to do tonight.
You said we don't have homework.
In what alternate universe are you living in?
You said this.
I did not.
Are we okay?
Alright. It's you okay.
No, 'cause
Hey.
she went for it. You can just get the homework.
I could,
You should.
but I'm planning to. I'm not gonna give a lot though. They get like 6 or 7 questions.
That's a lot.
Did you say that's about how much?
Y'all really wouldn't have liked my
Okay.
daughter's chemistry teacher, even I was appalled at the amount of homework she had.
Yeah, I do it.
Wait, I think I,
No.
the pressure is it
They said depression.
Yes.
Can we just get this and stuff?
I know, I always do. Application problem number 3 on the back.
is it that worksheet from last time?
Yep. What'd you get?
I think I did this wrong.
What was it?
I got 26.3.
I gotta say 6.9 about our own.
It's fine. It's fine if you round it and got a slightly different decimal place.
I got slightly different.
It's fine. If I just wrote 26, you'd never questioned it.
Okay, no question.
Yeah.
So, it's like the first math iteration on each thing.
When you need the media center nugget, for lunch or now?
And I need one. Can you put this up there?
Like Chris on Wilson, we had never finished, right?
It's right there.
It's like,
I tried to find it. I failed.
What's the date?
I'm determined what I got.
What are you going for?
Sorry.
Huh?
we have one now.
Have one, staff meeting, yes. Yeah.
Can't be long.
That can't be.
We'll be all locked in. Locked in, locked in.
Well, you know, is what it is.